Hello folks, I'll be talking about population density in the quantitative reasoning class. It's a simple subject, and I'll go through some examples. So quantitative reasoning, when we say population density, it can be easily found in Wolfram alpha for any state, for any location, but mainly what we talk about is, I can just say it's simply the area divided by the population, or depending on the problem, it can be population divided by the area. So it really depends on the problem. It depends what type of needs you have for a particular problem, and we will see that in the next example how to figure that out. So it says find the population density of Atlanta. So we have actually two options. Either you can do the first thing I can say, you can use Wolfram alpha. So you simply do like a Google search. So I go to website, I'm gonna write here Wolfram alpha. See, it just automatically shows on Google. So I go into Wolfram alpha, and here you can simply type population density of Atlanta, and you search it, and it will simply show us. See, it says 3,652 people per square mile, or we're going to be using this alternative one, so we can just write that one down. So 3652, so it's 3652 people over square miles, or it is 7,630 square feet per person. So we're going to be using the second one in our examples, but this is just one way to do it, by using Wolfram alpha. Next, so how we do this now in the actual calculations is that, for example, let's say we want to do the second one. So you need to figure out the area of Atlanta. So you could do the same thing. This time you just say we want to figure out the area of Atlanta. So we just see that it's 3.71 10 times 10 to the 9 square feet. So the area is equal to 3.71 times 10 to the 9 square feet. So next we look at the population. Of Atlanta in the same way. So we got 486,290. So 86, then 290 people. So now we're going to be dividing these two numbers each other. So it's going to be 3.71 times 10 to the 9 divided by 86, 920. So this is This is feet squared, and this is people. So we expect to get something similar to what we have in here. So I open the calculator, it's 3.71 and then divided by 486,920. So I got this. So it's 7.6 times 10 to the negative 6. That's what it means. So it's like, and there's also 10 to the 9, so it's 7. Just write that 7.62. So it's 7.62 times 10 to the negative 6 times 10 to the 9, and if you get this, gonna be 7.62 times 10 to the 3, which is 7,620 feet squared per person. As you can see, we get something so similar. Since we used approximations, and I can say the numbers that might be not updated according to recent years, but we get something close. So this is how you get it. So if you know the area and if you know the population, then you divide it by each other to get the population density, or you simply use Wolfram alpha. So it's completely up to you. So now we will work on this problem. It says what states would be required to house the entire population of the world if the population density was of Atlanta. So let's just take the population density to be let's say the population density of Atlanta, let's take it to be what we find, 7,620. This is feet squared per person. So of course, for this problem we need the population of the world. So you can again go to Wolfram alpha, or it doesn't matter, like you can do a simple Google search. Population of the world. It just gives us 7.55 billion. So billion will be 10 to the 9. So this is 7.55 times 10 to the 9 people. So if you look at the area required now, if you look at the area needed, this is gonna be 7,620 feet squared per person multiplied by 7.55 times 10 to the 9 people. So you see these two will cancel, so we're gonna get the area. So area required, so let's go to calculator. It's 7,620 times 7.55, so I get 57,531. 57,531 times 10 to the 9 square feet is needed. So let's go down. We can rewrite this, the actual scientific notation. So it's going to be 1, 2, 3, 4. So it's going to be 5.75 approximately times 10 to the 13 square feet. That's what we needed. So it's like we have here the decimal point here, so that goes 1, 2, 3, 4. So it just comes right here, 5.75 approximately times 10 to the 13. This is what we need. So now, so this is the area needed. Now we need the area of, it says this, we need to check California. So we need the area of California. So let's take a look at this one from, again, Wolfram alpha. Area of California. So if you look at this in square feet, that's what we need. You see it says 4.56, 4.56 for 10 to the 12. So 4.564 times 10 to the 12 feet squared. So this area will not be enough. As you see, the required area is just more than that one. Right, that more area is needed. So this is how you figure out these type of problems. I hope this video will be helpful. Thanks for watching. Bye.